And so we're now moving on to our next panel. I'm really delighted that one of the New Energy Nexus board members has agreed to moderate this panel, Challen Simmons. And I'd like to invite Challen up onto the stage with me. I really appreciate her taking the time and having interest in participating in our symposium today. The panel is focused on electrifying transportation and really figuring out what's the roadmap to ubiquitous adoption. And so, Challen, I'll ask you to take it away and I'll exit stage left.
Hello, everyone. Thank you for joining us on this Electrifying Transportation panel. I'm so excited to be here and introduce you to some of our amazing panelists who will be speaking about this very relevant topic. What I'd like to try to do is sort of allow them to introduce themselves a little bit, but first I'd like to introduce you to Reginald Garcia of Future Motors. Also joining us today will be Paul Francis of KIGT, as well as Stephen Chung of Rejoule. I'm hoping I'm pronouncing that right. Rejoule, and then work with me here, Chia-Lin of Cuberg. And so I would love to have the panelists perhaps introduce themselves as well as share with us a little bit of what their companies are working on. And then we'll head sort of straight to some questions, and then we'll reserve about 10 minutes at the end of this panel for your questions. Reginald?
So I think Lauren is bringing up our panelists onto the stage right now. The first panelist is Reggie Lopez. Reggie, are you joining us on the stage? If Reggie's not ready, potentially we could move on to our next panelist and come back to Reggie when he's able to get on the stage. And the next panelist is Paul Francis.
All right.
Here we go. Okay. And so Lauren will change the slide to the KIGT slide. And Paul, am I pronouncing your company's name properly?
Sorry about that, yes.
Yeah, it's all good. It's KIGT.
Okay, great. Yes. So Lauren's going to pull up your slide any second and we'll be on our way.
All right. All right. So thank you, everybody. Good morning for joining. Of human habit. And we say that and we believe it because we manufacture the smartest, fastest, most flexible level 2 smart charging station for electric cars. What we have done as a team was create a level 2 product that enables us to have a vertically integrated software network that comes with regulatory measurements such as onboard credit cards, such as EMV insert, back-end dashboard, or cellular and Wi-Fi connected as well, but also 4G, because we understand that in the future, you have to have faster network connectivity, and some chargers at the level 2 will have to be uprooted, and our 4G network comes to to be participating in pilot testbed with our project electric vehicle energy for rivers testbed energy nexus for selecting connected to a microgrid of a megawatt of solar and battery are charging the ability with algorithms to throttle power in real time to electric vehicles. And an EV project will be able to utilize blockchain to help with predictive measurement so that we can have smart billing features to enable stabilization. Just imagine when you have millions of vehicles. What we've been able to do is work with automotive OEMs with medium duty. We're introducing our level 2+ charging station. We're excited about that because it's a elegant, as we say, alternative to DC fast charging. That some of our projects we're doing in South LA with churches, we already have installations, issues with infrastructure where potential for DC fast charging because utility infrastructure doesn't meet those standards. So level 2+ charging is elegant. So you can have 80 amps charging 19 kilowatts, and even project allows it at a UC Riverside's campus, 25 charging stations at Caesar. And the cool thing is, we'll throttle power and be able to demonstrate how to go from 80 amps down to 30 amps in real time. Demonstrate vehicle medium duty vehicles and contactless charging with facial recognition with our new touchscreen features. So really, really excited. We're fortunate to really demonstrate how we connect our system with 15.11.8 in our Charge Cloud network. Thank you, everybody.
Thank you, Paul. That was amazing. I'm very excited about your technology, and I can't wait to hear more about that as well and the impact on electrifying transportation. And so I'd love to have the next panelist introduce herself as well as her company. So
Stephen Chung is our next panelist from Rejoule, and Lauren is going to invite him up to the stage and pull his slide up. Hi, Stephen.
Nice to meet you, Stephen.
Hi. Hi, everyone. So I'm Stephen Chung, co-founder, CEO of Rejoule. Our mission is to maximize the value of every battery. So EV and stationary storage batteries are large and expensive assets that are expected to last 8, 15, sometimes 25 plus years. But how do you evaluate the residual value of an EV battery after a 3-year lease? Or how do you measure the performance and remaining life of a 10 megawatt hour stationary storage system after 7 years? These are things that no one's really figured out yet, but it's really important for things like insurance, warranties, and financing. So there are many challenges to evaluating battery performance, including battery testing takes a lot of time, requires some specialized equipment, and high voltage battery testing is not yet really a common skill in the workforce. So at Rejoule, we're developing a scalable battery grading platform that can quickly assess battery pack health. And that can kind of address a lot of those challenges I mentioned. The technology is based on a technique called electrochemical impedance spectroscopy, or EIS. And with that, we can glean insights into battery degradation in minutes rather than hours. That's quite a big improvement in time and testing. So we're commercializing our technology in several stages. Today, we're finding homes for used batteries. So we're the happy recipients of a different Energy Commission award where we'll be demonstrating the cost effectiveness of our fast battery grading technology for a variety of used battery types and chemistries. And in the future, we plan to embed our technology directly into battery packs or into the EVSE charging networks. This way, we can continue to measure and even optimize for battery life in real time. Ultimately, this allows for seamless battery lifecycle management, which will help to accelerate us towards a sustainable energy transportation. So we'll be trialing both our fast battery grading tech as well as our EIS-based battery management system at UC Riverside. We're doing 3 things in particular. The first is we're aging some battery packs with real world duty cycles, and that's with some of their equipment for testing high voltage, high power battery packs. The second thing is they're helping us perform some reference performance testing and calibration on those packs. That'll give us some data to help validate some of our SOH algorithms. Third, we'll be trialing our real-time EIS tech in a live system. So that's very exciting. We're working with UC Riverside, which will help provide some much needed third-party validation that our potential customers are always asking for. We're excited to work with Mike Todd, Matt Barth, and the other amazing people at CE Cert. Currently, we're looking to engage in proof of concept projects with battery pack makers and OEMs, and early next year, we'll be kicking off our seed funding round. So if any of that sounds interesting to you, please talk to me. Thank you so much.
Thank you, Stephen. I believe our next panelist is, hopefully I'm pronouncing this right, Challen of Cuberg.
Cuberg, yes.
Sorry about that.
Yeah, that's fine. Yeah. Okay, should I? Okay, I'll just wait for a slide to update. All right, good morning. My name is Challen. I'm a senior scientist at Cuberg. It's great to be here to talk about the company. Cuberg is a startup commercializing a next generation battery technology to power the future of electric mobility. So the battery delivers a generational improvement in energy density and safety compared to the best lithium-ion battery in the world today. The technology is based on a proprietary non-flammable electrolyte combined with a lithium metal anode and high nickel cathode. It is a complete drop-in solution that leverages the robust lithium-ion manufacturing base and supply chain. Over the past year, we have shipped out our commercial 5 amp hour pouch cells to customers in the defense, aviation, and automotive industries to have the technology evaluated and integrated by those key customers. Earlier this year, we collaborated with Idaho National Lab, who performed a valuable third-party validation of our 5 amp hour cells. So the study showed that our battery can achieve a cell-level gravimetric energy density of over 320 watt-hour per kilogram, which is impressive, and a cycle life of 350 cycles at C/2 charge and 1C discharge at room temperature. The cell also shows equivalent performance at elevated temperature at 45 degrees C. Another good demo of our technology is shown on the bottom right here on the slide. We made a video of comparing our technology versus state-of-art lithium-ion batteries, specifically designed for drones. So it showcased that the drone that equips our battery can achieve 70% longer flight time. So this really captures the advancement of our technology for aviation applications. You can find the full demo video on our website, and it's quite interesting to watch. Certainly, we don't want our technology to stop here, so we are quite pleased with the opportunity provided by Call Testbed to collaborate with Lawrence Berkeley National Lab to continue our understanding of our lithium metal systems and exploring strategies to improve critical battery metrics that are important to our industry customers. Our next step commercialization plan include continue establishing partnership with leading battery material companies and also pack design companies. We also want to deliver aviation battery modules by end of 2021 for electric aviation customer validation, and also build out internal cell production capacity to satisfy customer demand for next 3 years. Yeah, thanks.
Share with us whether or not you guys will be raising money in the next round and what that looks like.
Yes, so we are also open to all sorts of financial options. Yes.
Fantastic. Thank you so much. And I think we have one more panelist that I'm hoping that we can bring on the stage. That would be Reggie Lopez of Future Motors.
Yes, Lauren is working to get Reginald onto the stage, and she is going to change the presentation to the Future Motors presentation. Sorry for the technical difficulties that we had getting Reggie onto the stage initially. And Challen, thank you very much for your flexibility as we pivoted.
No, and for my poor pronunciation.
Oh, no, that's okay.
Apologies. I have a horrible to pronounce name, so I feel awful when I don't pronounce things right. So bear with me, folks, as I go through the process of learning these company names and names themselves as well.
I wanted to ask if you wouldn't mind providing a little bit of background on yourself do a little introduction of yourself. I introduced you as a New Energy Nexus board member, but could you give us a little bit of more background on your experience?
Sure. My background does not always seem obvious in terms of participation in the green energy space, but where my background lies in terms of this particular panel lies in my work in transportation and transportation technology. Prior to my startup, which is in AI, I worked at a number of different companies such as Google, Amazon, but probably for a longer period of time, I have been the VP of marketing and business development for a company that is a connected vehicle company that basically exited to a large corporation that then exited to Samsung. I'm also a board member of a global privately held company that is very focused on the automotive and automotive sort of future mobility space, where I do, I'm on the board of the company and help them basically with investments in future of mobility as well. So very excited to be here in terms of green energy as well as transportation sort of intersection.
Excellent. Well, thank you so much, Challen. I appreciate it. It looks like Lauren is pulling up our panelists onto the stage. Reggie may be experiencing additional technical difficulties.
There's a fire taking place near him, so he may be having connection issues. So he's going to try to restart everything, and then we'll maybe have him present at the end. So just wanted to apologize for that, and we're working to get that done. But we'll go ahead and kick it into the panel.
Thank you so much, Lauren. I appreciate it.
Thank you. And we hope that he's doing okay and is able to join us at the end of the panel. And so I'm excited to be here with Paul, Stephen, and Kai-Sheng. And so I'm just going to go ahead and sort of kickstart this discussion. So yeah, I'm very excited to have this panel discussion with every one of you guys, because as you know, we are looking at 2020. There has been a real start in terms of electrification of transportation. It may be interesting for folks to know that, this is not the first time that, the technology market has been sort of focused on electrification of transportation. In fact, in the 1900s, 28% of all cars were actually electric. But by the time 1920 rolled around, the electric car had all but vanished. And so that confluence of legislative sort of work, industry coming together wasn't matched in 1920 for that to happen. And so fortunately, we're now at a time when clean transportation and mobility is highly supported at the policy level, local, state, and national, as well as with a tremendous amount of industry support that we're seeing today. And so I would love to sort of get us into some discussions around what those opportunities look like, how does those pieces fit in. To set some context to our discussion, I'd love to sort of talk a little bit about sort of where we are today. Looks like EV sales, when we look at automotives, is up. OEMs are planning to release hundreds of new models. Market research currently shows that EV sales are approaching 2.3 million vehicles worldwide. It's about a 2.5% penetration rate in 2019. So we are in a very sort of good situation, looks like, for personal vehicles and adoptions potentially for EV moving forward. And so, on our panel today, we have some amazing companies and executives that are in the battery-related technologies, motor innovations, smart EV charging, and so forth. And so, the big question really comes down to, the question for all of you guys to answer, which is, the three key dimensions that EV industry is developing clearly supports greater EV adoption. So regulation incentives, battery technology, and charging infrastructure. So how has your technology been supported by these regulations and incentives and, and the changing infrastructure to sort of help with EV technology?
Right.
Maybe I can.
Yeah, go ahead, Stephen.
Quick start. So for Cuberg, we kind of secured millions of fundings from grants, including California Energy Commission, DOE, NSF, CalSeed, and US Armies. So these resources, I think, are critical for us to build a minimum viable product, right? I mean, this is kind of the fat word for startup industries, but like when you talk about battery startup, the minimum viable product is actually a functioning batteries, and these resources are super critical for us to get a functioning prototype, and then that attracts basically attention from potential customers, right? And then this fuels this virtuous cycle that we get feedback from these critical customers, and then these feedback clarifies our development directions of our initial battery technologies. And then that attracts, for the customers, we collect more feedback, and then we just make iteration really, really fast to a point that, we meet the customer need. And then we go on to the next stage to scale up these technologies. So the early financial support, I think, from all of these regulations and also incentive programs really provided the funding sources to pave the way for early success of building the prototype, which is critical, right, to meet the customer need. And then and also I mentioned about the kind of the development direction of our technology, which after talking with the customers, it seems that right now the market we want to target first is with the aviation industry, which our technology fit really, really well with that, right? So as our technology matures and the cost reduce, then we are aiming to get into more mass market, such as the EV industry, right? Which is the biggest I think market for the battery companies. Yeah.
Fantastic, Stephen.
Yeah, I agree with pretty much everything that Kai-Xiang said. Directly, we've been supported tremendously just with grant funding to get our technology to higher TRL to get to the prototype phase, and so that's been amazing. I think indirectly, vehicle sales obviously are rising. California has these targets for not just commercial or not just passenger vehicles, but also commercial vehicles for electrification. So I think that's all driving a lot of demand for new technology. And so that's indirectly helped us a lot. One of the markets we're focusing on right now is second life batteries, so repurposing used electric vehicle batteries. And we're focusing on that because we see kind of a direct path to commercialization there. And for the second life market, at least, regulations in the US have been kind of slow. It's been a lot quicker in Europe and Asia. And in the US, it's more about we'll kind of see what happens. I think ultimately the market will go in that direction because the economics will drive all the automakers' decisions. We're gonna gravitate towards a more cost-effective solution. But I think with regulation, it can get us there a little bit sooner.
Paul.
Absolutely. Regulation has helped our company tremendously in terms of when we think about innovation, frontline communities, and ratepayers, especially on the innovation side, right? We've been fortunate to become an approved Southern California Edison charge-ready vendor. And due to PUC regulations, it's enabled us to participate in their Charge Ready 2 program. Because as a young company, we weren't enabled to participate in Charge Ready 1. So that has allowed us to get the RFP for public parks and schools. We're really excited to make that announcement with SoCal Edison. In terms of working with the San Diego Convention Center, we're able to install our charging stations there and leverage some of the DR programs. As you guys all know, FERC has it's like the old deregulation now. V2G, alternative energy sources now can actually generate capital. And so we're really excited about that. So some of our demonstrations with power throttling with the convention center has helped us kind of get that project going along. And then ratepayers, right? When you talk about the nostalgia feeling of gasoline with our software, when you will go to the pump and say, give me 10 on number 3 and unleaded. So in the future, when you talk about grid stabilization, if we're able to throttle power and give you the choice to pay a lower rate to charge at maybe 30 amps or 1.6 kW, now you have grid stabilization, you have price, you have choice, and some of that, the regulations has helped us on the innovation side infuse that into our technology. and has helped us to get deals, which is why we're going to install over 100 in this upcoming quarter with our technology. And a lot of that is due to the rebates when you have in disadvantaged communities. A lot of financing and investors now want to finance projects because of these rebate opportunities that they can leverage to recoup their investment. And then we've been fortunate to get into the NYSERDA program in New York because of regulatory and New York's investment into EV infrastructure. So we've benefited greatly, especially during the pandemic.
And are you seeing, as companies and startups actually based in California, I believe Stephen had mentioned that, some of the legislation and sort of policies are potentially a little bit slower when it comes to some of these areas. And are you guys seeing opportunities overseas for electrifying technology, for your battery sort of products, as well as for your charger products? And what are you seeing that's different between sort of the US market and its policies versus those on a global, other countries?
Well, we were fortunate at KIGT to travel to China with Rejoule, and we kind of benefited from that as a group to check out NEO and kind of show China about battery technology and especially how level 2 plus maybe perform areas. We were fortunate to discuss some folks in the Middle East about charging, especially in Africa. Our new grid will be removable. You have those people in the future. Critical. We talk about little kids homework underneath street. So imagine they can have an EV, and now that EV is able to power live. Talking to emerging markets to give us opportunities because of the software capacity. Multi-family projects there that will connect us to Asia Pacific markets on utilities that we've been speaking
with. Stephen and
yeah, I can chime in there as well. We've similarly, had a lot of there's a lot of opportunity all over the world for our type of technology, and I think that at least for us, we're talking about our customers are automotive OEMs, battery manufacturers. So these are typically large multinational corporations. Where if they have an interest in the U.S., they also have an interest and a presence in Europe and Asia and all the other places in the world as well. So there's definitely interest, and in terms of regulation, we haven't, other than the Second Life battery one that I mentioned earlier. It's more about just faster adoption. So in Europe and China, there's much faster adoption of electric vehicle technology than in the US. But that's not saying that in the US, it's not also growing at a fast rate.
Yeah, I'd love to sort of jump into that because that sort of segues into a question that I had around adoption. Right? So it seems to me sort of the adoption for volume revolves around potential consumer demand for EVs, which is very difficult to predict, obviously. And what you're saying is that you're seeing a little bit more in China than perhaps here in the US market. When we looked at the recent McKinsey report, it says that consideration for EVs has increased, I think on average around 21% over the last 3 years, but specifically significant EV concerns still persist. They have this as a consideration, but the purchase is still lagging the consideration. And I believe some of the concerns that they talk about is regarding battery and charging, driving range, higher costs, and those things potentially prevent a larger scale consumer purchase versus consideration. So can you share with us a little bit about sort of what you're looking at as part of your company in terms of addressing some of these concerns that, could prevent sort of a mass adoption of EV, purchases by consumers? I know that a lot of investors, when they think about sort of mobility, aeronautics is a really great area, to focus on, but they're thinking, who's the consumer driving in the car, and lots of interest, but not as much purchase. So what are some of the things that you think, your companies are working on that could actually help with those concerns, driving range, charging, and all of those things? Sorry. Paul, you want to jump in? Very obvious sort of questions related to charging, right? So.
Yeah, no, I was gonna, yeah, sure. So when it comes to charging, especially with the Cal Testbed project, with Project Even, Level 2 Plus is huge for our company in terms of trying to complement battery technologies. When you look at degradation, DC fast charging is going to be important, especially for interstate and long range trips. However, when you look at underserved communities, when you look at just kind of the population of car ownership in California, where over 70% people have a pre-owned vehicle, I don't expect that trend to change with EVs. And so you're looking at older battery life. When you look at Amazon's investment of electric vehicle fleets, when you have a business, it's all about the bottom line, and preserving your fleet and your batteries will be important. So when you have a level 2 plus charger, I think we complement that well with batteries to try to prevent that degradation, extend life of the cars. And then when you have the capacity to do power throttling and based on demand response events and schedule it, if you have a fleet that's sitting, I think our charging software and our hardware can complement that, especially when you talk about V2G, trying to give some stuff back and balance load and stabilization if you potentially have battery storage at a site. So I think what we're doing and raising that seed round upcoming to help us support that even more with the Cal Testbed is how we view battery technology in the future.
Kaishal, your thoughts?
Yeah, I agree. I think one of the major hurdles, I think, for EV adoption is really the cost, and the cost is really complex problems, right? Like battery technology, and it can affect like multiple aspects of the cost, right? There's the raw material cost, there's the manufacturing cost, there's also kind of when you build a pack, and then there's a pack cost as well. So for us, as I mentioned earlier, right now we're kind of targeting the premium market, which is the electric aviation, and for them, the cost is really not the primary target, and they are more sensitive to other metrics, like for example, core emission energy densities. But that doesn't mean like in the future we're not getting into the EV market. I think as the technology matures, right? I mean, there are like so many next generation batteries out there, right? For us, we're doing lithium metal, and there's also silicon anode, and then there could also be innovative cathode company out there. So as the technology matures and the cost reduces, I think these next generation battery technologies can also improve some aspects of the cost. For example, if you have a higher volumetric energy densities, then the pack of the battery pack can be smaller, so potentially it can be cheaper. And also, if you have battery design, a new chemistry that can operate at a higher temperature, right? So the whole thermal system can be simplified, and that can also reduce the cost of the pack and hopefully overall cost of the batteries. I think like the future is really bright for all these innovative technologies, battery technologies out there, right? So with help from government incentive like the Cal Testbed, we can actually spend time to think about the deep scientific problems, right, and to solve it, and then hopefully oriented towards the same direction that the EV market is going, which is reduce the cost, right? And also, as I mentioned in my slide, we're also working with other companies throughout the value chain, like for example the pack designers, right, to think about innovative ways to design a pack around the innovative battery technology that we're developing as well. So it's a complex system, and yeah.
Yeah, I agree there. Cost is how our technology is primarily going to drive greater EV adoption. And I'd say that in two ways. As I mentioned, we're looking at second life batteries right now, doing a lot of cost modeling. And with used batteries, the biggest question is always, is it going to cost more to test those batteries than to just buy a new battery pack, because everyone knows the cost of new batteries keeps falling and falling. So that's something we're looking at very, very deeply right now. And if we do have greater adoption of second life batteries, then that's a guaranteed revenue stream later on in life for a battery pack, which can really change the cost equation for buying a new battery or a new electric vehicle. And the second way is with our fast battery diagnostic technology, we're also able to look at the residual value of a used battery. So if there's an EV that's been leased for 3 years, right now a lot of used car companies don't know how to evaluate that battery, and a lot of consumers kind of fear that, well, we've heard there's battery issues, we don't know how long it's going to last. So if we have a kind of technology that is able to assess that and provide that certainty for a used vehicle, then that's going to make greater access for everyone of electric vehicles, not just the early adopters that we're seeing right now.
Actually, I love the fact that both you and Paul and Kai-Ting have mentioned sort of the affordability aspect of it. And so that seems to be one of the factors. I believe, Paul, you mentioned that, majority of the vehicles in California is about 75% used vehicles. And so what are some sort of, how is your company working to ensure equitable access to electric mobility options? What are some things that you're thinking about related to that? I know that, Paul, you have some, amazing solutions there. And I'd love to sort of get a better feel for whether or not from Stephen and Kai-Ting, you guys are seeing this in a sort of upstream because you're in a battery aspect of things.
Yeah.
Paul, you want to take a lead on that?
For sure. So for us, we have several projects in kind of these frontline underserved communities, and access is critical when you look at just affordability for charging. Many folks are unbanked. They do not have a bank account. And unfortunately, they won't be able to participate in charging because much of our competition requires you to be part of their network. So what we've done is create a program for income eligible people to charge for free to plug their car in when they have an EV, especially at level 2. When you're talking about trying to figure out how to have more access in apartment complexes and MUDs, because a large population of California rents as well. We're really focused on working with developers and getting our charging stations in multifamily complexes, often in these DAC communities where we manufacture our products. We have the capacity to manufacture 1,000, and our manufacturers are in DAC communities. So part of our whole entire ecosystem supply chain is supporting these communities where we develop and install. Our team, DAC is not just income level, but, air quality. And a lot of our team comes from the city of Ontario. Brandon Aparicio and Karen Diaz are UCR grads, and they're head of our software and their project management, they're chemical engineer grads. And so for them, their models and innovation in software, some of these ideas I'm sharing with you guys, because they come from these communities where affordability and accessibility are critical. Instead of having DC fast charging everywhere, we think level 2+ is good for having 80 amps and 19 kW. So you don't have to invest hundreds of thousands in infrastructure in these underserved communities. And once again, they can become left out because it takes weeks or even years to get approval from the utility. So we think that's just how we're elegantly making it that it's accessible for all folks.
Fantastic. So Stephen, Kai-Ting.
Yeah. As I mentioned in the previous answer, we're looking at evaluating used electric vehicles, and I just looked up the statistics. There's a large portion of car sales are used, and so as we get more EVs on the road, there's going to be a bigger demand for used vehicles. And another article that I just came across was that, especially right now during the pandemic, people are gravitating more towards vehicle ownership than taking public transport. So I think this is for the foreseeable future, at least, this is going to be a trend. And so we're making it much more accessible, the used EV car market. And the second thing about accessibility, not so much in terms of sales, but I think we haven't really talked about job creation yet so much. There was a Bay Area battery summit a few weeks ago, and I heard a statistic about 97% of mechanics don't know how to work on electric vehicles. And that's crazy, right? And if we're really talking about by 2030 or 2035 having only electric vehicles in terms of new cars being sold, then we need to change that figure dramatically, and that's where I think something like better tools for understanding and evaluating battery technology as just general maintenance is going to help a lot there, and just creating jobs locally for the local communities.
Fantastic.
Yeah, I just want to add a little bit about the technical side of this, kind of making sure the technology iterates fast, and but basically this the fast iteration allows rapid cost reduction. I think to achieve it, I mean there are a lot of great material innovations out there in the laboratory, but I think like new startup really have to think about innovative ways to how to practically bring that new technology, potentially cheap technologies to a working prototype, and then finding partners with big companies to put that technology into actual product, so that whatever is great on paper will actually be produced and delivered. And on that point, at Cuberg, so we really adopt this kind of innovative R&D and a manufacturing approach, which is to use a contract manufacturing, right? So we basically just focus on one aspect of the batteries, which is the electrolyte, and then basically leverage the manufacturing from across the globe. So the purpose of that is really to iterate really fast. I think this kind of model to build a prototype using this new electrical material is critical, right? Because a lot of the time we talk with customers, and their feedback is that there are a lot of new battery technology that's supposed to be cheap, and they got published on a daily basis, but then it's really hard to get tested of that material. So I think for entrepreneurs, and especially in the kind of renewable energy industry, really have to think about innovative ways for the business model as well, right? So that we as a community can bring those new materials to the market fast enough, right, to kind of reduce the cost also at a rapid pace, right, to ensure equal access to bring down the cost of EVs and ensure equal access to that technologies. Yeah.
Is it okay if I piggyback something on what Stephen was saying about opportunities with jobs? So yeah, so for us, we were in Hawaii last year with I was with my chief tech officer, and I was asking him, what is it that we do as a company? What type of business are we in? Are we a tech